Pythagorean theorem, part 2. In this triangle, right triangle, we want to find the value of x, and we want to estimate that value. So we know that there's a relationship. Well, first of all, let's label this part. The side opposite the right triangle is the hypotenuse. Okay, so we're starting with x. This will be y, this will be z. So this is z. 6 inches equals y, so x, y, z. And we'll just call this hypotenuse, and I'll just abbreviate it HYP. Okay, so we know that there's a relationship called the Pythagorean theorem, where we know that x squared plus y squared equals z squared. Or in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So this is a leg, and this is a leg. In other words, x squared plus y squared equals z squared. Now we can substitute some values in here. Instead of writing x, well, we still have to write x because that's the value that we're looking for. So we'll just leave x squared. And for y, I'm going to put in the value of 6. Again, I'm just going to leave the inches units out for the purposes of simplifying this problem. And I'm going to put 6 squared. And z, we know, is 9, and that's squared. So our first step is to substitute. Our next step is to do the exponents. So I have x plus 6 squared is 6 times 6, which is 36. 9 squared is 9 times 9, which is 81. Now I want to solve for x, so I have to subtract 36 from both sides. This is 0. I have to borrow 1, so that's 7. That makes that 11. And this is 5. And 7 minus 3 is 4. So x is equal to 45. Excuse me, I'm dropping the x square here. Shouldn't do that. Okay, now I want to solve for x, so I want to take the square root of both sides. Okay, the square root of x squared is just x. And 45 is not a perfect square, so we're going to estimate. I know that 7 times 7 is 49. So if I take the square root, here, let me write here, square root of 49, I know is equal to 7. The square root of 36 is equal to 6. So if this is a number line, the square root of 45 falls somewhere between there. Now again, we're just estimating here. So is 45 closer to 49, or is it closer to 36? Well, it's closer to 49. So we're just going to approximate our answer. So I represent that by putting some tilde one on top of each other. And the square root of 45 is approximately equal to 7, a little bit less. But for the purposes of this problem, that's close enough. We could look it up on the tables, or we could use a calculator to calculate the exact value of the square root of 49, which I think is about 6.708, something like that. At any rate, x is approximately equal to 7. So we can write x is equal to 7, approximately. All right, and that's it.